so let's take a look at the meninges. Now, meninges are membranes that surround the brain and spinal cord. And so this is showing, we have 1, 2, 3 layers, and so 3 layers to the meninges. Down here is on the spinal cord. We have 1, 2, and then 3 layers to the meninges there. These are membranes that are going to protect the brain and spinal cord. All right, so the first layer, the outermost layer, shown here in that like really whitish color there, that's a Dura Mater. So Dura Mater is the outermost layer of the meninges. It is made of a tough fibrous connective tissue covering. So anytime we have a tough fibrous connective tissue covering around an organ, it's going to prevent infections from spreading into that organ, right? So this is our main defensive functionings for our brain and spinal cord, because we don't want, so what we're trying to do is prevent stuff from getting in there, because once stuff gets into our brain and spinal cord, it's really hard to get out, because a lot of our defensive functionings that we do for normal tissues, we don't want to occur in our brain and spinal cord, because some of our functionings, we actually damage our own tissue in getting rid of an infection, and then we repair that tissue after the fact. We obviously don't want that to occur in our brain and spinal cord, because if we damage any of these tissues, being neurons are amitotic, and so that repair process won't occur. Okay, so the next layer is called the Arachnoid Mater. So that's the Arachnoid Mater there. This is showing it here. So it's called Arachnoid Mater because it looks web-like in its appearance. Lastly is the Pia Mater. So this is the Pia Mater there. That's the brain itself. So here's the spinal cord. All right, so the Pia Mater is the innermost layer of the meninges. So it is directly on the brain or spinal cord. Now there is a space between the arachnoid and the Pia Maters, and that is known as the Subarachnoid Space. And that space is filled with cerebral spinal fluid. So if I go to this next picture here, everywhere where you see arrows is where cerebral spinal fluid is located. So you can see that all the way around our brain. This area right here is what is known as a third ventricle. So that's an area of the brain there. A cavity within the brain. Right, here's the fourth ventricle, another cavity within the brain. We talk about these in the lab portion of the class. Okay, so let's look at the functions of cerebral spinal fluid. One is protection. So our brain literally floats in our skull. So everywhere where you see arrows, once again, is where we have cerebral spinal fluid. So our brain actually floats in our skull, doesn't rest on our skull, and that's a good thing, because if it rested on our skull, the weight of the upper parts of the brain would put pressure on those lower parts of the brain, and those neurons would start to die. Okay? It's also a shock displacer. This can have good and bad effects. So if you get hit, it's going to spread that shock out, but then it can also spread the damage on that. Also, another problem with it, our brain floating in here, is if your head gets hit, your brain will shift around a couple of times in that as well. It also has a nutritive function, so it provides nutrition because it is filtered from plasma, that cerebral spinal fluid. Okay, let's look at the peripheral nervous system. Oh, this is showing the 4 ventricles in our brain. All right, so looking at our peripheral nervous system, let's first talk about the cranial nerves. And these are nerves that arise from the brain. All right, so we have 12 pairs of nerves that arise from the brain. So this is showing from top to bottom on these. So they're kind of numbered. You can see they're numbering 1 through 12 on here. Okay, and they kind of work their way all the way down to 11, then they come back up to 12. All right, so let's look at these individually. So the first are the olfactory nerves. Oh, by the way, these 12 cranial nerves that arise from the brain, they all originate from the brainstem. So that's midbrain, pons, or medulla oblongata. So the first are the olfactory nerves, and so these provide us with a sense of smell. Next are the optic nerves. So the optic nerves, they're going to provide us with a sense of vision. Next, after that, you can see them highlighted over here, are the ocular motor nerves. So the ocular motor nerves, they're mainly motor. They're going to raise the eyelids, they move the eyes, they adjust the amount of light entering the eyes, and they also focus lenses. So as you can see, some of those are somatic, some of those are autonomic in their functionings there. Next is the trochlear. So I should point out we have 6 muscles that move the eyes. The trochlear are going to help move the eyes. All right. Next is the trigeminal. So, there's the trigeminal there. You can see it here, branching off 3 ways. This shows it where it goes onto our face and scalp. So our trigeminal is sensory on the face and scalp. It's also motor for jaw movement. So me talking right now, using the trigeminal there for that. Next is the abducens. This would move for me, and apparently it's not. It's decided it doesn't want to do that anymore. So here is the abducens. It's also one that helps move the eyes there as well. All right. Next here, I'm going to have to constantly click through here, unfortunately, is the facial. So you can see where it is over here. There it is over there. So the facial is sensory for taste. It also is motor for facial expressions. That's where it gets its name. It also goes to our tear and salivary glands. Next is the vestibular cochlear. So here's the vestibular cochlear here. Here's it come here. So this is why it's called the vestibular cochlear. It goes to the vestibule, and it also goes to the cochlea. Now the vestibule is where we sense equilibrium, and the cochlea is where we hear. So that's what it does. All right. Next here is the glossopharyngeal. So the glossopharyngeal, glossal refers to tongue, pharynx is our throat. So the glossopharyngeal is mixed nerve, so we get sensory and motor for the tongue and pharynx. So this is one of the guys that we sense taste through. All right. Next is the vagus. So here's the vagus here, and you can see everything that the vagus goes to. It's a large nerve, goes to a lot of parts of our body here. So it is a mixed nerve. It's somatic in that it controls our larynx, that's our voice box, and also used in swallowing there. It's autonomic in that so here it's sensory and motor with autonomic for a lot of the organs of our thoracic and abdominal pelvic cavities. So you can see all the stuff that it goes to there. Next is the accessory. So the accessory nerve here, it's motor, it controls our soft palate, our pharynx and larynx. It also controls some neck muscles, and that's what you see it going to here. Lastly here is the hypoglossal nerve. The hypoglossal goes to our tongue, and it helps move the tongue there. All right, so let's look at spinal nerves. So spinal nerves are nerves that arise from the spinal cord. And as I said, so here is just showing one segment of our spinal cord. And as I said earlier, we have 31 segments of the spinal cord. So each spinal nerve, so here's the spinal nerve, has 2 branches to it that you can see there. So this branch right here is the dorsal root. So the dorsal root conducts impulses from the peripheral nervous system to the spinal cord. So inputs are coming this way. So that is sensory, is what's going through there. And here the cell bodies are located within ganglia, so that there's that dorsal root ganglion. Next is the ventral root. There's the ventral root right there. So this conducts impulses from the spinal cord to the peripheral nervous system. So we're going out from the spinal cord, out to the body. So motor impulses are going that way. Okay, so let's look at our autonomic nervous system. So these are portions of our nervous system that control the actions of the viscera. So our autonomic nervous system is all involuntary. We don't consciously think about this. So these are things that are going to keep us alive without us consciously thinking about it. So it maintains homeostasis, and it functions independently and continuously without conscious thought. 2 parts to it. These 2 parts to our autonomic nervous system go to all the same organs. So we have the parasympathetic division and we have the sympathetic division. And as you can see, they innervate or go to all the same organs. Our parasympathetic division, shown here on the red part there, this is a division of our autonomic nervous system that controls the normal activities of the viscera. So, your normal digestion, normal breathing, stuff like that. The neurotransmitter associated with this is acetylcholine. And so the portions, the parasympathetic division arise from portions of the brain and also the sacral region of our spinal cord. Okay? The sympathetic division is on the right side, my right side. Sympathetic division is our division of our autonomic nervous system that activates the body to cope with stress or excitement, or the 4S response. So fight, flight, freeze, and mating. And you can think of a synonym for mating that begins with F. Anyway, so its neurotransmitter is norepinephrine, what we commonly call adrenaline. So this arises from different areas. It arises from the thoracic and lumbar regions of our spinal cord, goes out to the same organs.